Now let's take a look at the flip fluids. We are going to create the water simulation, fluid simulation by using the flip fluids. Let's see how we can set it up. I'm going to go into this object level and create a geometry node, empty geometry container. Let's dive inside. First we need the source of emission. I'm going to create a sphere geometry, and this sphere will be act as our source for our water, for our fluids. Let's go into this sphere and let's move this up. Now we need to create a DOP network. Let's add this, and I'm going to just connect this onto the very first input. We might need to reference this. Let's dive inside the DOP.NET. In here we need the flip object. Like all solver, we have the flip object. Let's add this, and we need the flip solver. Let's add the flip solver, and here we have it. The very first input is the object. Let's connect this, and I'm going to connect this onto the out. And by default we see some of the particles. Here you can see we have some particles, and these are coming from this flip object. If I go into the flip object, here onto the initial data we have the SOP path, and right now it's using this default fluid path, importing this cube that is actually came with the default directory of the Houdini. I can make my own SOP path. Onto the SOP path, let's click on it, and from here I'm going to just select my sphere, hit accept, and up here we have the input type. Right now we are using the surface SOP. Surface SOP mean that it is expecting the geometry node. And if we go back, here you can see we have this sphere and it is a geometry node, which means that if we go into the DOP.NET, we have our sphere imported and it's now working. If I were to hit play, nothing will happen, as you might have guessed. We need the forces. Let's add a gravity force in here. Let's connect this, and it should fall down due to the gravity. Let's add a ground plane, so that we must have something to collide with. Let's add a merge node, and let's merge this with our solver, and let's organize this, and let's hit play. And here we have our very basic fluid simulation. Right now we have a very coarse resolution. Let's go into the flip object. I'm going first go to the very first frame. Let's go into the flip object. We have the particle separation, and this particle separation will control the resolution of our simulation. By lowering this value down, we will going to be create more particle. If I were to change this to 0.03, and here as you can see we have lot more particles, and right now they are a bit hard to visualize. That is because by default Houdini is using the sprites as a visualization. To actually change the visualization, let's go into the guides tab, and here you can see we have the particles visualization enable, and its color is blue, and we have this corresponding option for the visualization. Let's go into the particles, and here you can see the visualization is set to sprites. Let's change this to spheres. Now we can see bunch of these small spheres, or I can also change this to grains or particles. Let's change this to particles because it is a very lightweight visualization. Let's change this to particles, and let's hit play. And here as you can see, we can see the visualization. I'm going to enable the real-time playback as well. Let's hit play. Here as you can see we have the visualize as particle, and we can see all of the particles. If I can increase the particle separation, I'm creating less of the particles. By using the sprites visualization, it will also give us the visualization of the scale, and we can control the scale from this particle radius scale, and it is a multiplier. If I were to lower this value down, here as you can see we are adjusting the particle scale, and by default it is a multiplier of 1.2, and this particle scale will going to be generated for us from this particle separation. If I were to increase the number of particles, here as you can see our particle size also get increased, and same thing if I were to lower this value down, we will going to be creating more particles, and the particle scale will also going to be decreased also, and this particle radius scale will just as a multiplier. Let's change this to the default, and we actually do not need to visualize this as an sprite because Let's change this to particles. It is a very heavy in the visualization, and particles are very lightweight to visualize. Let's hit play, and we have our very basic fluid splash. Now we have the blob of our this fluid, and it is splashing onto the ground. And if you zoom out, here you can see we have some of these boundaries. These are the bounds in where our this fluid simulation will live. It has its domain, and we can control the size of our domain, and the size can be controlled from the flip solver. Let's go into the flip solver and enable the parameter, and it should be on the volume motion. Let's go into the volume motion tab, and here you can see the very first is the volume limits, and right now it is visualized. If I were to disable this, the domains are there, but we're just not visualizing it. I can enable the visualization, and I can even make my domain size smaller. Let's continue lowering this size down. Let's continue lower this down to a very low size. And I'm going to also move this box a bit up. And now our simulation will only going to be lived inside of this domain, and all of the particles that will try to leave this domain will going to be deleted. And here, as you can see, I can go into the flip object, and we have this option closed boundaries. If you were to enable this, it means that all of these domain, all of these bounds will now act as a collider. Instead of cutting off, we are going to colliding them, which means that I actually do not need this ground plane. I'm just going to remove the wire from here, which means that now these bounds will act as a collider. If I were to hit play, here you can see our particles will not going to be cut off, but they will going to be collide with this domain. And before that, if I were to go into the flip object, and if you disable this close option, the particles will going to be just deleted. And here you can see, let's enable the close boundaries, and now the particles will act as a collider. Sorry, this domain will act as a collider. Right now we are importing this blob of particles, this blob of fluid, and simulation is taking care of all of the simulation. I want to continuously emit my particle fluid, and to actually continuously import this, we need to go into the flip object, and let's go into the initial data. Let's delete out this saw path. We don't want to initialize anything, but let's use the source node to continuously emit our particles. And if you type the flip source in here, flip source, and here you can see we do not have a flip source. And that is because this flip solver is a combination of volume. If I take a look at the solver, here you can see we have the volume, and we also have the particle. So it is a combination of, you can say that, the smoke solver and the pop solver. We have the volume motion and the particle motion. And to actually import the source, we are going to use the source volume, the same volume that we use to import our smoke simulation or pyro simulation. And here we have the volume source. Let's add this. And the very last is the for sourcing. Let's connect this onto the volume source. I'm going to change this to input. Right now it says SOP. I'm going to change this to first context, because as you remember, we have plugged this into this first input. And here you can see our source is not being imported, which means if we go into the volume source, first we need to initialize this. And if I were to try to initialize this, let's say I want to source the flip, because we are working with flip simulation. Let's click on this source flip, and nothing is happening. And that is because we must need to convert this polygonal geometry into as a flip source. Inside of the SOP, we have a flip source node. If I type flip source, and here we have the flip DOP source. Let's add this and connect this. And when you convert this into source, what this flip source node will do, it will convert your geometry into volume. Here as you can see, I can visualize the surface volume. First, it's convert this into surface volume, and then we also have the particles in it as well. If I were to middle mouse button, here as you can see, I can see points. I have 500 particles, and I also have a 1 VDB volume, and it is a surface volume. It's doing these two things. It's creating the particles and volume. I can go into the flip source, and here you can see I have the voxel size, and that define the voxel size of our volume. Down here we have the particles, and we are also creating the particles as well, and we can adjust the particle separation from here to create more or less particles. And to maybe better visualize the particles, I'm going to click on this output fog. It will just change the visualization to fog. And here you can see this voxel size control the resolution. If I were to increase this, I'm creating very coarse resolution of our volume. I'm going to lower this value down, and the particle separation, that will control the number of particles. If I were to lower this value down, here you can see I'm creating more and more particles, and same thing if you were to increase this, we are creating less and less particles. Let's default this out, particle separation. Let's default out the voxel size. Now I'm going to connect this onto the first input. Let's go into the DOP.NET and dive inside, and here you can see we have our source imported. Let's go into the volume source, and here you can see when we initialize this to source flip, it imported the surface volume. And if we go back, as you know, we have the surface volume in here, and we also have the one particle group, and the group name is set to particles, where we have all of the particles. Let's go into the DOP.NET and onto the volume source, and let's go into the particles tab, and here you can see we are importing this particle group, and we are killing all of the particles inside of the DOP surface. And right now it's not doing anything because in the DOP we do not have right now any surface, and that's why this has no effect. But we are actually importing the particles. That is important. If I were to go back and hit play, and here you can see now we are sourcing our particles, and we are importing our particle source every frame. And that's how you can basically configure your flip simulation. I can go back in here onto the flip to create more of the particles. I can play around with the particle separation, and this value should be linked with the value that is available on the flip object. If I go into the flip object, here we have the particle separation. Let's copy this parameter. Let's go back and onto the source node, onto the particle separation. Let's paste this to relative reference. Now we are working with the same particle separation. Let's dive inside and let's simulate this again. Now we will have our continuous emission of our flip fluids, and our particles are now colliding with the boundaries of our flip. So that is the very basics of flip simulation.